A very warm good morning to all. We have with us today Ms.shijimol A.K, Infrastructure Modernization Specialist, Google Cloud, our alumni from 2005 pass out, and Mr. Sundar Pelapur, Customer Engineering Manager, Google Cloud. They are here to conduct a talk on disrupting the status quo, how cloud and artificial intelligence is shaping the future of our world. Without further ado, I welcome you all to this session.
Alright, so I think we'll get started, while I settle in. We'll start off with the agenda for today. So, this is the agenda. So, we have, we'll start off with a brief introduction of myself. I share this brief, but we'll just give you more context, and then we'll start with the impact of cloud computing. We'll talk about artificial intelligence, how cloud and AI work together, how you can start your journey in the cloud, and some additional resources. So we'll start with, I'll hand it over to Sundar. You can just introduce yourself. So really great to have you here, Sundar, especially for me as an alumni matter of College of Engineering in Poonjar. It is as alumni of College of Engineering in Poonjar, it is really great to have you here as a speaker. Please go ahead, Sundar.
Thank you, Shiji, and welcome to all students. I think looking at the classroom, I remembered my own college days, right? Although long time back. Thank you so much for having me here. So I am Sundar Pelapur. I lead the customer engineering team that's focused on a section of business for GCP, Google Cloud Platform India. I've spent close to 22 years now in the industry. Done various roles, right, as you can see there, so I won't read all of that. But essentially, as much as I like to work, I also like to play. So I play tennis and do a bunch of things. All work and no play makes us a dull point anymore. So that's what I believe in. I think work-life balance is also super important for me. And I know as students, this is the time when you can shape all of these tenets going forward. So that's what I do at GCP. Right? Gigi, thank you. Back to you.
Thank you so much, Sundar. Just to intro about myself, I can read there, but I've been in the industry for 17 years now. So I passed out from College of Engineering Poonjar in 2005. So really always feel great when I'm back here talking to the students, sharing my experiences and whatever way I can help the students. It feels really wonderful. So in the past 17 years, I've worked in different companies and different industry verticals. So I got into cloud somewhere like a decade back, and I started working on one of the public cloud platforms. So I've been engaged in different communities, I've written talks and a couple of things as well. So it feels really good to come back here and share my experiences and knowledge with all of you. So with that, we'll get started. So how we have structured this talk is we have put together some nuggets of information about what cloud is. You might be, you might have heard about cloud. You might have read about it in articles or news items, and you might have even and I'm sure all of you are using cloud as well. So we'll come to that as well, right? And also we'll talk about another important topic, which is artificial intelligence and how it is impacting our world in different ways. So let's get started. We'll start with a little bit of history. So the history of computing or history of cloud computing can be traced back to the age of mainframes. So I'm not sure how many of you here have heard about mainframes. Raise of hands in the room or in the chat. Yeah, nobody have heard about mainframes? Wow. Okay, so mainframes were there, they are still here. Okay, so mainframes are where the whole gamut of computing started. So these are like huge computers. You can imagine a computer filling a room. So that is your mainframe. Okay, a room or two. It is central processing. It processes a lot of data. And how you access it is you access it through computers connected to that terminal, right? Connected to that system, and you run your programs there. Okay. So I myself had a little bit of experience before I started my IT career. I have learned a little bit of mainframe. So it's a now legacy system, but it's a very important system that is used in a lot of industries. Okay. Then we graduated to server and client systems, right? Server and client. I hope server and client everybody must have heard, right? At least let's be active. I know that you guys just came out of an exam, but how many of you have heard about server client? I need to see a lot of hands here now. Raise of hands, server client systems. Folks, you're studying in your exams as well, right? Yeah, okay. So, yes, we see a lot of server and client system, which is like small factor, which is that means, you have a server sitting in a server room, and then you have a client connecting to that server, accessing the applications hosted in that server in very simple terms, right? So, that is the client's server, small factor based distributed computing. Okay, the server can be anywhere and you can connect to it over the network, right? So that is the era of 1990s to mid 2000s. From there, we started talking about private clouds or even private data centers, right? So that means, large pool of on-premises compute resources. When we say on-premises, think about a room. You might be seeing servers in college, right? You would be having a small room or a small place or a small cage even where you keep your servers and connect it to the network. So imagine it in a larger room, or like a data room or a data center as we call it, where you keep all these compute resources and you create a cloud out of it. Cloud is like when you when you think about that term cloud, it has different aspects. Say one important aspect is elasticity. So you may not be using the entire capacity. You might be using a part of it, and you will use some more of it when you need it. It is the elasticity that we're talking about. Okay. So there might be 10 servers, and you might be dividing that compute capacity among different applications that need it. Okay. So that is the concept of cloud and private cloud, because it is still on-premise. That is why it is private cloud. Now, public cloud is where it goes beyond your private data centers, beyond your private data rooms. And think about renting a compute capacity from a large service provider. So this started in late 2000s. Until today, it is one of the most biggest technologies that we have now, right? We have compute capacity available on demand that can be used. Okay, so that is cloud computing. Now, let's start by defining cloud. Let's drill down, let's double click and understand what is cloud, right? So it is nothing but when you hear the term cloud, don't get confused, don't think that there's so many things. At the bottom of it, at the basic concept of a cloud is compute and storage. That means, you are taking a compute capacity. You need to run a program. You need a compute power to do that. You need a processing power to do that. So that is what the cloud offers. You have data. You have to put data in a storage. Okay. You have to put it in a hard disk. Or think about it like you might be having external hard drives, right? So you must be copying data to there, your movies or songs or whatever it is, right? Similarly, you have a space in the cloud where you are putting your data, right? So that is, in some very, very simple terms, it is like renting some compute capacity and some storage capacity. So yes, there are finer nuances of it, of how we use cloud. So for example, there are different cloud models available. So I explained about data center. So data center is the place where you imagine a room where you stack up a number of servers, and then you deploy all your operating system, you deploy all your hardware, everything you deploy, you manage everything. You manage the power, you manage the network, okay? So everything is managed by you. So that is the data center concept, okay? So please, raise your hand or feel free to stop me if anything is not clear, right? There is no right or wrong questions. Okay, we are all here to learn. So if at all you have any questions, please raise your hand and feel free to ask it. Okay. Okay. So we talked about data centers. Okay. Next is about infra as a service. So infra as a service. So in cloud mainly you will hear about. There are different other services as well, but mainly you will hear about infrastructure as a service, platform as a service, and software as a service. Okay, so that means in infrastructure as a service, you will not be actually working on the server hardware. Okay, the server hardware is provided by the vendor. It could be any cloud service provider. They will just provide you the hardware. So you have to install the operating system. You have to install the application. You have to run the application on top of it. You have to manage your data. So that is infrastructure as a service. Okay. Next is platform as a service. You don't want any of that headache. You just have some code. You want to deploy the code somewhere. If you have written a very wonderful application, you want to deploy that application somewhere, right? In that case, what you will do? You will opt for a platform as a service. Say for example, you have a Python program. So what a platform as a service will provide you is a runtime for that. Okay, so a runtime with all the required libraries, operating system, everything is taken care of. We just deploy the application and it will run. Okay, once the deployment is successful. Next is software as a service. Okay, so in that, imagine that you are not doing anything at all. It's a service. Okay, so for example, your email, right? A Google Mail or Gmail, right? You're not doing anything. You're just signing up and then you're using it, right? So that is SaaS. So any other examples of SaaS from the room that you guys can think about? I am sure that you're using a lot of applications in a SaaS model today. So I want you to give it a thought and let me know in the chat or from the room any software that you think is a SaaS. Anybody? Think about it. I told you mail. Mail is a very commonly used application. I don't want you to think about the exams you have just written. Just come out of it and just think what is the software that you think is a SaaS model. Anybody in the virtual room? Anybody can put in the chat. Netflix, okay. Yeah, it is. You're not putting your videos there. You're not building the solution. You're just signing up and using it. Right? So that is correct. That is pretty much correct. Yeah. Okay. So now moving on. There are different type of clouds as well. Okay, you will hear this terminology very quite often in terms of private cloud, hybrid cloud, public cloud. So what is private cloud? I explained earlier, local data center, you manage everything, you will have a room and then you will make sure that there is redundant power, the cooling has to be maintained because all these machines generate a lot of heat, you have to ensure that there is redundant network connectivity, so everything is managed by you and that is a private cloud. Public, I'll come to hybrid cloud later. Public cloud is where you rent out that capacity. So somebody else is doing all this. Somebody else is actually having a room with all these servers, stacked. Everything is taken care of somebody else. And somebody else is the cloud service providers like Google Cloud Platform or Azure or AWS. But you are renting out that capacity. So that is public cloud. That offers huge scalability. Okay. Now, in between these two is hybrid because certain customers want to use both public and private cloud. Okay, say for example, sensitive data people sometimes want to keep on premise. Don't want to put it in a service provider data center. In that cases, they might go for a hybrid model, okay, which will have components of both private and public cloud. Then there is multi-cloud. So that means you may not be using just one cloud service provider. So you may not be just using Google Cloud or Azure. You might be using all three. So that is also another model of fusing cloud. Yeah. Now, why cloud computing? So we talked about having data centers, building data centers, and using the capacity and all that. Right? You have to do the entire stuff by yourself. Now, with public cloud, you are getting that massive scalability. We're talking about petabytes of data and huge compute capacity available on demand. So that means one is your IT cost is much reduced. So when we talk about IT cost, it involves the cost of the room that you are renting, all the physical stuff required there in terms of the cooling or your generators or whatnot, right? And then you need regular maintenances and all servers have an end of life. You have to recycle those servers. So all that cost that goes into it is gone away, right? We call it as capital expenditures or capex. Okay, that converts into operational expenditure, which is OPEX. That means you pay as you go. You want one small server, small capacity, you buy it and you pay for it, right? How easy and how simple is that, right? So that is the flexibility and scalability offered by the cloud. So imagine you want 1 petabyte of data. So you're running a large project, you want 1 petabyte of data. So imagine how much of a storage you have to buy and keep and maintain if you have to do it on your own. Instead, today what you will do, you will go to a cloud, you will get that capacity on demand, use it and pay for what you are using, right?